Well, happy Friday, boys and girls. All you people out there, get ready for a geometry lesson. Go ahead and put your Facebook and Instagrams away. Turn off the television and tell your boyfriend or your girlfriend to quit texting you because, hey, it's time to get started with some geometry. Today, lesson, answers above. Everything's up there. Check your answers. There you go. Always good to check your answers, especially in a math class. And today, I'm excited to let everybody know this is the last lesson in Chapter 11. This is it, folks. I can't believe that this chapter is so short. There really is one more section after 11.4, but because we're on quarantine, I have to cut out lessons here and there. So 11.5, although a great lesson, I have to cut it. So we are ending the chapter at 11.4. So let's take a look at this really quick. So last Friday I taught you 11.1. This past Monday, a couple days back, I taught you 11.2. On Wednesday, 2 days ago, I taught you 11.3, and then today is 11.4, which is the last lesson. Which means, you guessed it, we got ourselves a Chapter 11 quiz on Monday. So, good news, bad news. Bad news, well, you got a quiz on Monday. Good news is there's no homework that you need to, do, which is all right. Today at the end of the lesson, just like in Chapter 10, if you remember what I did, I'm not going to give you homework from 11.4. Instead, I'm going to give you the review guide. I'm going to get you the review guide. This is not due at midnight tonight. This is going to be due on Monday. The review is going to be due on Monday, and your binder is also going to be due on Monday. And your binder, hopefully this is easy. I don't think you're going to have to take as many pictures because, well, you only have 4 sections of notes. So I need both of these on Monday. Before or after you take the quiz, it really doesn't matter, but I just need them on Monday. This is going to be a 10 out of 10, and this is going to be a 10 out of 10. Huge grade booster, ladies and gentlemen. Get those submitted to me by my email. We got less than 3 weeks of school left. Just hang with us, folks. Keep doing your homework. I know it's tough. At home, getting all your homework done from all your classes, it's not the best way to learn, but just keep it going. Summer's almost here, quarantine's almost over. Just keep hitting it, folks. Alright, that's enough said. I'll get you the review guide at the end of this lesson. So this lesson is one of those lessons that you're going to need to pay attention. It is a tricky one. I'll just be honest with you. It's a tricky one. No sarcasm there. Area of regular polygons. Area of regular polygons. This is a tricky lesson, folks. Be ready, be ready. Okay. I would like to start off with a nice, wonderful picture. I want to make it large because I've got a couple vocab terms that I want to throw in here. So I want to start off by making a perfect circle. Now, the better this looks, the easier this is going to understand. So try to make this circle a good one. Alright, I can live with that. Give this circle a center, please. And now I am going to make a regular polygon inscribed in this circle. Now I want to make a regular, let's go pentagon. Actually, back up for a second. Hopefully does everybody remember what regular polygons are? Regular polygons, in order to be regular, hopefully you remember this, the sides are all congruent and the angles are all congruent. So you can have a regular octagon would be an example of a regular polygon. A regular decagon, a regular pentagon, hexagon, heptagon. There's so many different regular polygons. It just needs to make sure that all the sides are congruent, all the angles are congruent. Let's go ahead and make a 5-sided regular polygon. So let's make a pentagon, everybody. I want a 5-sided regular polygon, but I want that inscribed in this circle. So go ahead and everybody make a point at the very top. I'm going to show you how to make a regular pentagon in here. I'd like you to make a point roughly about right there. Same thing on the other side. And then this is a little tricky because the distance between here and here has to be about the same from here to here. It might look good. It might not. Hopefully you see I've made 1, 2, 3, 4, 5 points around the outside. Oh, where's my ruler? I'm just going to have to use a straight edge. Grab a straight edge. Man, I do not have a good straight edge. Alright, hold on, folks. I'm going to find a ruler. I don't know who stole my ruler. It's over here in the kitchen. Okay, got my ruler. Coming back. You can't do math with it. You can't do math without a ruler. Alright. Go ahead and connect all these and make yourself a regular polygon. That is a pentagon. And let's see how regular it actually looks. If we did this right, all the sides should look of equal length. And all the angles, I mean, we don't really have a protractor with us, but all the angles should look like they're about equal. And then we can put our stamp on it and say, hey, it's a regular polygon. Alright, the pictures in the book are a lot better. Alright, not bad, not bad. You know, we got ourselves a regular 5-sided polygon. We've got ourselves a regular pentagon. So hopefully you remember these sides are all congruent and all these angles are exactly the same. That's what makes it a regular polygon. This could be 5 sides, it could be 8 sides, it could be 14 sides, whatever. That's what makes it a regular polygon. Okay. Let's see, what else do we need? What else do we need? Okay. I would like you to connect the center to each of these 5 vertices, please. Actually, let's just start with one, shall we? Let's just start with this bottom one to the left. So connect those two. Folks, we call this a radius. We call it a radius, you know, because it's the radius of the circle. Pretend like the polygon is not there. Pretend like the pentagon's not there. That's a radius of the circle. It's also what we call the radius of the pentagon. It goes from a center all the way to a vertex. And you can make a whole bunch of them. In fact, I think I'm going to draw every single one. Let's go ahead. Go ahead and draw the radius to the top vertex. And go ahead and draw them all. We're starting these notes off with a picture. But this picture is important. Stay with me. I hope I hope you're drawing this and not just staring at a math teacher, just drawing a pentagon. I hope you're drawing this with me. It's important. Alright, so we've got the radius. There's actually 5 radii on this little image right here. Okay, so we got that. Let's go up here. I'd like you to mark this angle right there. We call this a central angle. And if we went back to chapter 10, that's exactly what I called it back there as well. A central angle is an angle that comes from the center of a circle. There's a central angle. So that's a central angle, that's a central angle, that's a central angle, that's a central angle. The cool thing about a regular polygon or a regular pentagon is that, and please write this off on the side, all central angles are congruent. Every single one of these angles, 1, 2, 3, 4, well, it's a 5-sided polygon, so there should be 5 central angles. Every single one of these are exactly the same. Question: how do we find the angle measure of one central angle? Think about that with me. If there are 1, 2, 3, 4, if there's 5 central angles and they're all the same, and I know that from here to here is a full rotation, 360 degrees. Let's do 360 divided by 5 equal central angles. We'll Get my calculator out. 360 divided by 5. That's 72 degrees. Every single one of these angles are 72 degrees. Write that down. Super, super important. 72 degrees. Okay. We got the radius of the pentagon. We've got a central angle. We got something more coming your way. I would like you to take this center point. Now this is important, folks. I'd like you to take this center point, and I'd like you to drop the altitude to down to one of the sides of the pentagon. So let's go and drop the altitude. Do we remember what an altitude is, folks? An altitude is another name for the height of the triangle. So notice how we have a whole bunch of triangles in here. That's the height of the triangle. Drop the altitude. It makes a right angle, but it does a couple other things as well. It's going to take this entire side down here, and it's going to cut it into 2 equal pieces. So this piece and that piece are exactly the same. So I'm going to do a double tick mark there. Also, it's going to cut your central angle in half. So that was a 72 degree angle. That's a 72 degree angle. They're all 72. If that's a 72 degree angle cut in half by this altitude, then 72 cut in half, I believe, is 36 degrees. So this is a 36 degree angle, and that's a 36 degree angle. All right, this altitude has a special name, everybody. This altitude right here is called the apothem. Here, turn it sideways so you can see. A-P-O-T-H-E-M, apothem. So we got a couple vocab words coming your way. We got the radius, we have a central angle, we have the apothem. Oh gosh, I think that's all you need to know for this so far. That's all we need to know. Okay, hold on to all this. I'm going to be referencing every single one of these words, and we're going to kind of jump into our first example. So, here we go. Example number 1. I would like you to find the area of a regular pentagon. So I'm going to use the image that we just used. I think I'm going to draw another picture because I wasn't really happy with that one. Find the area of a regular pentagon with, or maybe I'll use that, maybe I will use that picture. Save us a little bit of time. Find the area of a regular pentagon. Penta is 5 sides, we already drew it, with apothem of 10 centimeters and a side length of 12 centimeters. So the apothem is 10, a side length of your pentagon is 12 centimeters. Let's go back. 10 and 12. 10 and 12. I want to go back. We're going to save a little bit of time, folks. 10 and 12. So the apothem is, make sure I get it right. Apothem, 10 centimeters. So this apothem is 10 centimeters. The distance from here to here. And the side length is 12. So from here to here. That's a side length of a pentagon. It's 12 centimeters. Did I get that right? I don't want to screw this up. Find the area. Okay, find the area of a regular pentagon with the apothem 10 and the side length is 12. We're doing this so we can avoid drawing another picture that's exactly like this, because this is a regular pentagon. So the apothem is 10 and the side length is 12. Now we're going to find the area of this entire shape. We're going to color in just the pentagon, not the circle, the pentagon. And the question is, how do we do that?